All right, hi, welcome back. This is the second portion of our lesson. Part of it got recorded, part of it didn't, so I'm trying to recreate it after school. We've been talking about equivalent fractions, and everybody had a quiz. They had to give me two equivalent fractions for 1/2, 1/3, 2/7, and 3/5. Most everybody gave me equivalent fractions for 1/2. We'd worked on that a lot, but then the transfer of knowledge to 1/3 wasn't there, and it was even worse for when the numerator was no longer 1 for 2/7 and 3/5. Lots of confusion for people in the class. This is a drawing of a visual model. At first I had 1/3. Let me see if I can get some thicker lines drawn here. Okay, need a pen. Need it to be thicker. Let's see if I can draw it where it was originally. Whoa, a little too thick. Too thick. Okay. So we had, whoa, still too thick. Okay, maybe I can't do this right now. I don't know why. We'll put it maybe right there. So we had our original third here, which now is covering things up. And our other original third was here. So this bar graph was cut into thirds, and the first third of it was shaded yellow. Then when we cut it with the pink line, we had 2 out of 6, and then 4 out of 12, and then 8 out of 24, which is where I think we left off. Then I was going to draw a visual model of 2/7, and I'm going to go to the board. Hopefully you can hear me. Prior to that, my first attempt at doing this was when I tape recorded it with the webcam with an orange Post-it over it. So we do have audio from the lesson, but not any visual. So here's the audio from earlier today.
Does anybody disagree with 8/24? Is that what you see? Okay. So thumbs up, thumbs down, thumbs in between. Where are we at now? I want to see. How do you understand? I got some that are a little bit more than that. Some people are still not getting them. Some people are getting them. Okay. How many people, raise your hands down for a second. How many people feel so good about 1/2 equivalent fractions and 1/3 equivalent fractions that you can explain it to someone else? You could teach them. You got this, you hands down. Okay, if you're still having confusion, did you see those people? That's somebody's above Steve. He's got the here. This one is tricky because the numerators here and here were just 1. But is it any different when you have a numerator with a different number? It kind of is a little different. I don't have room to draw this on top, so should I draw it under it? Or should I draw it on the side? Side? Okay. I'm going to draw with the left. I'm going to draw an up and down bar. Now I have to figure out, this could be tricky because 7, they don't even make fraction powers from 7. They could, but it's tricky. So I'm going to have to cut this into 7 equal parts. It's not. I'm trying.
Do they look the same size?
The way that I do it is I go a little bit farther than halfway. Uh-oh. Okay, I'm going to stop in 26 seconds. So if I'm shading in, highlighter. I wonder if the highlighter will work. Oh, cool. So I've shaded 2 out of the 7. You guys see that? Now, if I divide it, and I divide it in half. Oh,
Oh, I did it again. I used the highlighter on accident. So I divided it in half like this. This is where the audio stopped, so hopefully YouTube doesn't load up another person talking while I'm doing it after school here. I've cut each part in half, so now if you count the total number of smaller squares, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That becomes my new denominator because it's how many parts make up the whole thing. Now, if you look at how many were shaded white, which looks kind of light bluish now, if I count those, how many are there? 1, 2, 3, 4. So my numerator would be 4 pieces because 4 pieces are colored out of 14 now. In class, I asked the question, when you look at the numbers, what did I do to the 2 to change it into the 4? And, a lot of times kids could say one of two answers, but I think it was Cannon who came up with the right answer. He said times by 2. So if I take 2 and I times it by 2, it's going to equal 4. So that's what I did to the 2 to change it into a 4, which my equal sign is bothering me. Sorry, I really need to fix that. And then I've been telling children, whenever you're working with the numbers, it's an identity property. 2 over 2, which is your fraction. This right here is multiplying the first fraction by 1, because 2 over 2 is one whole thing. You selected all 2 pieces out of 2. An identity property, anything times 1 gets you the same number. But with fractions, it's a little bit different. The identity property actually tells you a new number that is a new fraction. However, it represents the same amount, which is where you get that identity property. So 2 times 2 does equal 4, and 7 times 2 does equal 14. So you can manipulate it either by drawing your visual model or by multiplying the numerator and denominator by a fraction that equals 1. So that's what we did in class. And then we decided for the next fraction, people talked about dividing those halves into halves. How far backwards can I go? Go. So I needed to get rid of all my dots and my lines. And now I have 2/7 again. But we already figured out that it was equal to 4 what? 4/14. If you said that, you're correct. Then we did something fun and different. I'm going to change colors. And instead of drawing one straight line down like I did before, instead I'm going to draw it so I cut each column. Instead of one big long column, I now have 3 in each piece. And I reminded students that it's 7 going down and it's 3 going across. So it's like an array. 7 times 3. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. If you said 7 times 3 is equal to 21, that's my new denominator. That's all the wholes, all of them all together. Now to figure out the numerator, we need to look at what part. What part are we looking at? Yeah, it's the shaded part because that's the part that it has been selected. So it is 3 in the first row and 3 more makes a total of, you thought 6, you were correct. That is the visual model that shows 6 21sts. If you are timesing the denominator by a number, what do you have to do to the numerator? That's right, times it by the exact same number. And then 2 times 3, does it get us to 6? Yes, it does, because 2 groups times 3 in each group gives you 6 altogether. So that is what we did for 2/7. Then we did 3/5. I just wanted to look at my picture for a minute. Yeah, that's what we did. Okay. Sorry. I drew a rectangle model again, and I chose red. And then once again, it's hard to cut things into fifths because you can't get a half out of it. So when I look at a bar model, I estimate, right about here, a little more than half. And I draw a line.